This assignment is called 3 pegs, n discs. And the reason it's called that is because we're going to be looking at a game and counting the number of steps it takes to get to the solution. And then we're going to use that data to model the situation. So in math, when you observe something in the real world and then you use math to describe it, that's called making a mathematical model of the situation. So the game that we're going to be using later is the game where you have 3 pegs, 3 sticks, and then you have discs that are over here on the left-hand peg. And the goal of the game is to move 1 disc at a time and move them all over to this peg. So in the beginning, it looks like this, and in the end, it would look like this. So that's the game we're going to be using later to make a mathematical model of the situation. But first we're going to look at this sequence down here that doesn't have anything to do with the game. And our goal is to write an explicit formula to show this data that's in this table. So remember that there are 2 kinds of formulas for sequences. There is the recursive formula, and there's the explicit formula. So in the recursive formula, we use the term value that came before. So this column right here where it says X, that's the column for the terms. And this column right here where it says Y is the column for the term values. Right? So these are the terms and these are the values. So in the recursive formulas, we explain the pattern using the value that came before. So recursive formulas use the value that came before. So for example, in this, if you're looking at recursive patterns or sequences, you're looking at this column by itself. And you're saying, how do you get from this number to this number to this number to this number? And the way we could explain that in English is we could say multiply the value by 2, right? Because 2 times 2 equals 4, 4 times 2 equals 8, 8 times 2 equals 16. So if we were writing a recursive formula, that would be the information that we would use to write the recursive formula. But we don't want a recursive formula in this situation. We want an explicit formula. So to write an explicit formula, you don't mention the value that came before. So you don't mention the value that came before. So, apologies for my hand. I know left-handed people, right? Our left hands get in the way when we're writing. But if you're writing an explicit formula, you don't mention the value that came before. So since we want an explicit formula, what we're going to do is we're going to try to see if we can figure out a pattern for how you get from this number to this number, right? So we're not going to make any reference to the term that came before. So we had some ideas in class. So we did some experimentation in class. We tried adding, but we saw that adding didn't work. We tried multiplying, and multiplying didn't work. Because here we're adding, if we added 1, right, we'd get 1 plus 1 would equal 2. But 2 plus 1 would not equal 4, so that doesn't work. So then we tried multiply. We tried 1 times 2 equals 2, 2 times 2 equals 4, but then 3 times 2 didn't work because 3 times 2 equals 6, not 8. But then someone in class had the idea of using exponents. So let's use exponents and find the pattern, okay? So what someone in class said, a classmate of yours said, what about if we use a base of 2, right? So then what that means is when you're using exponents and powers, what that means is you use 2 as your base, and then your exponent goes up here, right? So, and this is called the base, and this is called either the exponent or the power. So look at this pattern. Let's look at a pattern, right? If we do 2 to the first power, and then 2 to the second power, and 2 to the third power, and 2 to the fourth power, look what happens. So 2 only one time equals 2. So 2 to the first power, 2 to the first power equals 2. And then look at this, 2 to the second power. 2 to the second power means 2 times 2. And that equals 4. So 2 to the second power equals 4. 2 to the third power is the same as saying 2 times 2 times 2. And some people like to do this. They like to draw these little lines and say 2 times 2 equals 4. 4 times 2 equals 8, right? So you do them one at a time. 2 times 2 is 4, and then 4 times 2 equals 8. So look, 2 to the third power, 2 to the third power equals 8. And then 2 to the, it seems like our pattern is working. So 2 to the fourth power is saying, well, I'm running out of space here, 2 times 2 times 2 times 2, because we have 4 2's being multiplied. So 2 times 2 equals 4, and it also equals 4 over here. So now you have 4 times 4, which equals 16. Another way you could do this is you could just do the multiplication one at a time. 2 times 2 equals 4. 4 times 2 equals 8. 8 times 2 equals 16. But some people like to write it out like this to make it easier to do. if you're using your calculator, let me see if this shows up very well. If you're using your calculator, you can press 2 and then this little caret symbol and then your exponent, and it will give you the answer. So other calculators have a different symbol instead of the caret symbol. You might see a key that looks like this, where it says X and then has a little Y up top. Or some calculators have a key that has a Y with a little X up top. So on a calculator, you might see this, you might see this, you might see this, and all of these mean to do exponents or powers, right? So take a look at your calculator that you use and see if what symbol your calculator uses to do powers or exponents. All right, so now that we've got this pattern set, what we didn't do yet is we didn't write the formula for it. We figured out the pattern, but now we need to write a formula, okay? So what we're going to do is we're going to write the explicit formula, and there are a couple different ways you can do it. So in the past, what we did is I'm going to erase this to give myself more space. In the past, in our last lesson, what we did is we used a pattern. We know it's a geometric sequence because we're multiplying. So we did G sub n, and then we had a pattern of G sub n equals A sub 1 times our R raised to the n minus 1 power. And then what we did is we just plugged in our A sub 1, which means our first term, and we plugged in our R, and then we were done. So let's do that method first. So write G sub n equals, our first term is 2, so that goes here because A sub 1 means our first term, which is 2. And then we said already that we were multiplying by 2 each time. So our R is 2. And then we have our n minus 1. So what you might also notice, if you are lucky and observant, is you might see another way to write this. Instead of having these 2 2's here, it's also the same mathematically as saying the term you're looking for will be 2 raised to the n power. And in this case, our n power is this. So I wouldn't be disappointed at all if you wrote it this way instead. G sub x equals 2 to the x power. Because you're raising 2 to the x power. So you can write it this way, you can write it this way, you can write it this way, and there are probably even more ways that you could write the formula.